Winnipeg is studying the idea of bringing a car-sharing cooperative to the city. Car sharing has been successful in Vancouver since 1997. This graph shows the annual rates for a member on an occasional driver's plan in Vancouver, where the annual membership fee, including the application fee, is $80. Determine the rate of change. So do you guys remember how to do that? Yeah? Does anybody know what this point right here is? It is 80. And this point right here, can you get the change? We're going to measure the rate of change there. So the distance from here to here is 10, right? And the distance from here to here, yes, that's 150. So what's this distance? 70. It's going from 80 to 150. So my rate of change is going to be, and it's positive because it's going up to the right, right? So 70 divided by 10, which is 7. And what would that be in units? I'm sorry? $7 per, I guess, hours per year, right? $7 per hours per year. Okay, so now we have to do the C-intercept. What's the C-intercept? We already said what it was. What's the C-intercept? We already said what it was. What was it? 80. The C-intercept would be your Y-intercept, but it's just called C there, right? Yeah? What do they represent? Well, what does the C-intercept represent in this scenario? Yeah. Yeah. Annual cost is $80 without even driving, without even using car, I would say, something like that. Okay, and what does the $7 per hour per year mean? I'm sorry? What's this mean? The $7 per hour per year is the cost, yeah, for each hour, cost increase for each hour. Okay. Okay, so write an equation to describe the graph. So we got to use C's and H's for our equation. So remember how we put this together now? How do we put it together? We use the rate of change and our y-intercept, and we put it together. So C would equal yeah, 7H plus 80. Very good. Okay, any questions there? Okay, so that's review. So now we're going to go into the nitty-gritty here. Okay, everybody got this? Okay, so now what we're going to do is, obviously, these things, this is going to give you a scatter plot, and we're going to graph it on our graphing calculator. So let's look at example 1. So in 2006, Turin Winter Olympics, Cindy Clausen of Winnipeg, Manitoba became the first Canadian to win 5 medals in one Olympic game. IOC President Jacques Rogue called her the woman of the games. The table shows the winning times for the women's 1,500-meter speed skating since 1976. So we are going to now graph these. So we're going to put this into a list. So make sure you're paying attention here because it gets overwhelming all at once here. So the first things first is we need to, I'm just going to move this so I can see the numbers at the same time. Okay, so the first thing we're going to do is we're going to go to Stat. By the way, if you get lost in my keystrokes, look at the bottom, and then you can see where I was. So I pressed Stat first. Then I went to edit, number 1. And does anybody have anything in their lists right now? If you have anything in your list, the way you clear it is you go up to the where it's highlighted and go clear enter. And that'll clear your list. So if anybody has anything in their list, again, you go up to the list name and you go clear enter, and that will clear anything that's down there. So the first thing we're going to do in L1, that would be like your X or your independent. We're going to put the year. So we're going to type 1976, enter, 1980, enter. Does everybody know what I'm doing? We're going to put all that in. So I'm going to keep going here. $1992, whoops. Okay, so now we're going to go up to L2. And again, if you need to clear L2, go up to L2, go clear enter. Okay, and then we're going to put the times in there. So enter the times now. So this will be on your test. You will have to add a list to your calculator and calculate things from it. So we're going to go over this, and so hopefully you'll do enough problems that you will remember where to go and find these features. Does anybody remember how I got to this screen? Stat, then what? Then edit. Very good. Okay, so now we're going to actually, it'll actually plot it for you in a scatter plot. So the way you have to do this is you go to second y equals to get the stat plot. Do you see the stat plot? We're going to select number 1 for turning plot on. So we have to turn it on. So do you see how it's flashing on, but it's solid on off? We have to press enter on the on so that it's actually turned on. So just so you know, if you ever get into any kind of difficulty where something doesn't plot properly, it's probably because you have a plot on when it shouldn't be on. Okay? Okay, so where I went to second y equals. Then I went to number 1. So I typed in 1 for plot 1. And then I turned it on. I entered over, like this is flashing here, I pressed entered on it. Okay, so now we're going to go to zoom. Is everybody good? Okay, before I forget, we need to make sure that everything's the same as mine. So for instance, do you see this? Do you see how you have dots there? Remember when we plotted a scatter plot yesterday? We just did dots, right? We didn't connect it. Yes, and then later we did a line that best fit. We're going to do that in a second. We're going to do the line that best fit, but the calculator is going to figure this out. So then our X list, we have to tell it it's L1. If you ever have to name L1, do you see it's the blue lettering down here above the 1? And L2 is the blue lettering here by 2. So you'd have to go second 1 to get L1 and second 2 to get L2. And then this is just a matter of opinion if you like, you know, open squares or pluses or whatever to do it. And of course, mine is a more sophisticated calculator, so I can actually do it in different colors. There you go. You can change your colors. Okay. So now we're going to go to zoom. And all these different zooms are available. Right here, zoom's at the top. Zoom. Okay, so the standard viewing window that is basically from 10 to negative 10 to 10 and negative 10 to 10 in the y and the x, that's number 6. But we're not going to take that. We're going to take this zoom stat because we're doing statistics. Essentially, anytime you use data, you should be using number 9. So you can type 9, and then there it is. I'll plot it for you. Isn't that beautiful? Does this data represent a linear relation? You don't think it kind of forms a line here? A line that best fits? Like we were doing before? Yeah, it's not, like this is data, so it's not going to be exact, but this looks like it would form a line, right? So yes, it looks pretty linear. Obviously, there's some outliers there, but for the most part, it'll work. So now what we're going to do is we're going to calculate what that line is. Your calculator will actually find the best fit. It's not a judgment like how we were doing with how slope it is versus whatever. All right, so now we're going to stat. Everybody with me? Stat. Then we're toggling over to calc. So you use the arrow button to go over to calc. Does everybody know where I am? Okay, so now we're going to be picking number 4 for linear regression. So because we've determined that this forms a line, we're telling it to make the equation of that line. In grade 11, you'll be talking about quadratics. In grade 12, you'll do cubics and quartics, etc., etc. So we're going to be doing number 4. Okay, so select 4. And on this one, you have to make sure that it knows that your X list is your L1 again, and your Y list is your L2. Yes? Okay, so now we are going to go down to calculate, and we're going to press enter. So what does the A represent here? What does the A represent here? What does the A represent here, people? Yeah, it's the rate of change. Very good. Does that make sense? It's going down to the right, that it's negative 0.66. And then what does the 1,449.39 represent? The y-intercept, right? So in this case, the y-intercept is what? That's the time, right? That's the time. Okay, so now what we're going to do is, so it doesn't really help us to do it this way. It just, like, you can look at it, but what we really want is we want actually to graph this. So in order to do that, we're going to go to y equals, oh, I have something in there, so I got to clear that out. So y equals, I clicked. Everybody with me? Y equals. We're going to go to vars. Do you see the vars? It's right by the clear button. Then we're going to select statistics, 5. We're going to toggle over to the equation. And it's going to paste that regression into my y1. Do you see? There it is right there. Do you see if I go to the right? Do you see that's that whole thing? It pasted it all in there for me. If you ever have trouble, you could just try to type as much as you could that if you don't remember this. So what I did was vars. Statistics, number 5. Then I toggled to the right to get equation, and I selected number 1, regular equation. Okay? So now if I go to graph, look at that, and there's my line now. We want to analyze how good this line is to the data. And what it's called is called a correlation coefficient. Okay? So we are going to go to catalog. So go to second 0. And we're going to turn the diagnostics on. Sometimes it's easier to go up. No, maybe it's not. I thought, okay, well, let's keep on. Oh. We're going to get to diagnostics. To D, it's alphabetical. Jace, yours was already on. That's why you had the extra stuff. So you don't have to do this. Okay, so do you see there's a diagnostic on and a diagnostic off? If you turn it on, you'll never have to turn it back on again. It'll automatically be on. It's just because some of you have brand new calculators, you got to do this. Like, for instance, some people, when they had the A and the B, they had an R and an R squared on it. That's the diagnostics. So get to that one and press enter. Okay? So now what we're going to do is we're going to go back to our linear regression. Do you remember how to do that? So this is review. Try to do this by memory. You know how I got to the linear regression? Not the pasting of the equation into the y equals, but the thing before that. We went to stat, calc, for, calculate. What do you mean? Correlation coefficient means that if it's near 1 or near -1, it's basically a perfect fit for the line. The data fits the line perfectly. We got -0.91, so it's pretty close, actually. That's pretty close to being close to the line. So again, the closer it is to 1 or -1, the closer it fits the data. Because we got -0.912, fairly close to -1, so the fit is good. Okay? So all the negative means is it's because it's a negative slope. If you had a positive slope, it would be, say, positive 0.91, blah, blah, blah. This R squared we never look at. That's not in this course at all. We're only looking at this part right here. Okay? So let's keep going. Now we're going to do example 2. So before we continue with our calculator, we want to clear the y1. So how do I get to y1? Press y equals, get rid of this garbage there. Okay? So just press clear. Okay? Now we're going to go to stat, edit. Do you remember how to clear our lists? You go up to L2, go clear, enter. You go up to L1, go clear, enter. Do not press delete because you will delete the L1 completely. You go clear, enter. Now we're going to enter that list into L1. Okay? Everybody know what the list they're putting in? So the body mass is going to go into L1. So 46. 6. Are you keep going? 64. Ready to go. When you do your homework tonight, try to see if you can remember how to do this by memory instead of referring to your notes. That's how you'll get ready for the test, right? Okay, so now we're going to graph the points. It should automatically know to put it in L1, L2. So do you remember how to do that? Zoom 9. You see, now it looks like that. Now, can you remember how to draw the line that best fit? Don't say anything. Try it on your own, okay? But can anybody tell me what the independent variable is? Body mass. And what is the dependent? Number of drinks. Okay, so do you remember how to get the line that best fits? Okay. Remember, we go to our y equals. Oops. We go to our y equals. We go to our vars. We go to statistics. We go to EQ. And we go to reg E. Oh, shoot, I forgot to do we forgot to calculate it first. So sorry about that. Get out of here. Remember, we have to calculate our linear regression. Do you remember how to do that? Stat, calc, number 4. Then we go down and we go to calculate. There we go. Does everybody get that screen there? By the way, what the R equals 0.997, is that good or bad? That's really good, yeah. So now we're going to go to y equals. We're going to go to vars. We're going to go to stats. We're going to toggle over to the EQ and REQ, and then it pastes it in there. Then I go to graph, and bada bing, bada boom, there's my line. Okay, so there is my thing, and I'm just going to put my screen here, what this was. Oh, shoot, I'll have to do it again. Sorry. I just want to get the R value on here. Okay. So my calculator, draw the line that best fits. Describe the rate of change. What was my rate of change there? 0.044 is my rate of change. Remember, that's your A, the rate of change. What's the y-intercept? 0.382. What does that represent there? Well, the 0.044 is the number of drinks per kilogram, right? And then the y-intercept, of course, is the number of kilograms with no drinks, I guess. Okay, so write it. So we're going to write this y. I guess should we use y? Yeah, let's just use y equals 0.044x plus 0.382. So now I'm going to show you in about a minute here. Well, what's the R again? R is 0.99. I do want to finish this G question here, okay? If someone weighs 120, how many drinks could this person have in 2 hours to produce a so what we know, this is the coolest thing about your calculator here. If you know 120 is your X or Y, by the way? X. If you go into your graph and you go to calculate, so that's second trace, it's calculate. If you put in that X value for your 1 and you go X is 120, it'll find, oh, shoot. Oh, let me just go to quit. I need to zoom out first. I know this is getting a little crazy here. I need to zoom out for a second here. Okay, so now I'm going to go to second calculate value, and I type in 120. And it figures out, look at that, 5.73. So if you weigh 120 kilograms, you can have 5.73 drinks. Okay, so how I did this was, I need to zoom out. So it can't calculate, it was too restrictive of what the viewing window is, so I had to zoom out. So I went to zoom, and then the number 3 to zoom out, and then I just pressed enter, okay? So then my zoom out made it look like that. Then what I did was I went to second calculate value, x equals 120, and I got 5.7.